The goal today is to get this control cabinet wired and see some servos moving under control of the MASSO. Is it going to work? Or are we going to find a PCB problem that I created when I laid out the boards last November? I guess we're going to find out. Welcome back to Cloud 42. I'm James. Well, we're back on the MASSO CNC conversion of the Precision Matthews PM728 mill today. You'll recall in previous videos, we built the control cabinet, we made some custom PCBs for breakout boards, we got everything in the cabinet, got it all laid out, got all the connectors mounted, and now we just need a bunch of this. And there is miles and miles of wiring. Well, maybe not miles, maybe not kilometers, but there's a lot of wire that needs to go in this cabinet. I have my crimpers and my wire strippers and my wiring diagram all laid out. So let's just dive in. This thing's not going to wire itself. Despite all of the other things that have been going on in my life in the last couple of weeks, I have managed to make a little bit more progress on the control cabinet for the CNC. Most notably, I've done a bunch of planning. So I've got a spreadsheet where I've worked out kind of all the circuits, everything that I think I need to connect, figured out which power supplies those are going to be on, figured out which relays I'm going to use, and how everything's going to be connected. I think I've got everything here. I guess we'll find out when I actually start setting it up. So this is what I'm using for planning, and I've already started doing a little bit of labeling. So I've assigned all of the 12 relays that I have to different functions here, and I've labeled all of those just using a circuit breaker or a patch panel style label plan in my labeler, which went somewhere. You've seen this labeler in a previous video. This is the Dymo Rhino, and to date, this is still the best labeler I've found for doing the heat shrink tubing with the printing on it for labeling the wires for various reasons. But I recently upgraded to this. This is a Brother P-Touch Edge, and I did this for a couple of reasons. One is I was having trouble with the labels for the Rhino peeling off of cables. Any place where I had a label wrapped around a cable, they were peeling off. And Brother has some much better laminated industrial labels for that kind of application. This labeler will also print on tape up to 24 millimeters wide, so I can make much larger labels. That said, some of the other things about this have been super frustrating. None of this is sponsored. I paid for these both. But the user interface on the Brother, I am still not used to it. I'm not a fan, and I've struggled quite a bit with it. I do really like the Rhino, except for the label materials. I really like the label materials on the Brother. Maybe I will learn to love it. We'll see. But on the Brother, it is relatively easy to just say, I've got a patch panel. These are 0.51 inches wide, and there are 6 of them, and then just enter the text for all 6 fields and print those out. So I've got the relays labeled, I've got all the power supplies labeled, and I've got all of the basic power connected. I've got the AC input going through the breaker to the contactor. I've got a switch over here on the front panel wired up to activate the contactor. And then from that contactor, I have the power distributed through some terminal blocks to the low voltage power supplies. The main 24 volts for the MASSO, 24 volts for all the magnetic loads, and 5 volts for the fans and the wireless touch probe, or the wireless probe that I'm going to use. So that's everything connected for just the power. And I want to test this before I connect any of the stuff that's really expensive, just to make sure. Now, I have gone through and done some basic continuity checks, and I think I've got everything connected right, but we can connect the power and see for sure. So we should see, if I just go from a ground, I'll just reference from the ground here on the door, we should see hot power there, 122 volts, but nothing on the output of the breaker. Flip on the breaker. Now the output of the breaker is hot. Input of the contactor is hot, but the contactor coil is cold and the output of the contactor is cold. So then when I switch this on, we should see power supplies and fans. Okay, that hit. I hear the fans running. I see the lights on the power supplies. And if I check these over on the output, this should be the 5 volts, 5.1, This should be 24, 24, and this should be the other 24. Okay. I think that's good. We've got power. We've got fans. Throw the filter on that, and I think we are ready to start hooking stuff up. Let me get power connected to the servo power supply. Let me get some power connected to the MASSO, and then let's talk about how I'm going to get all of the connections from the MASSO, or at least from the wiring kit for the MASSO, out to the MASSO itself. The way the wiring kit's intended to be used, these cables need to come into the box and connect there. And I don't want to do that. So my plan is to make extension cables that go from these 37-pin D connectors down to the holes that I have in the panel down here. And to do that, I'm planning to use IDC, or insulation displacement connectors. So these are just crimp connectors that go onto a ribbon cable. So you just put it in there, squeeze it, and there are little teeth inside these connectors that pierce into the ribbon cable and make what presumably should be a good enough connection here. I believe the wires in here are rated for 4 amps, which is way more than I actually need. The MASSO actually pulls about 500 milliamps. It has a 1 amp fuse in it, so this should be perfectly sufficient. The trick is just to make sure that we get the gender right. One of these is male, one of these is female, and we just have to make sure we get the right one connected to the right one on the other end. And I'm just thinking about which way I want the cable to come out, and we just need to crimp it. Got my very fancy insulation displacement connector crimping tool here. Make sure I've got the red wire towards pin 1, and I do. And then we should be able to just crimp this down. That looks good to me. Then this should fold over like that. And there's a little back clip that snaps on. I've also considered whether I should split this. This stuff does just zip apart. And if I split it, then it should be a lot easier to route. Yeah, that's going to make life much easier. That's not ideal. Let's do it this way. Okay, I think that is all connected. And I've got the wires connected to the MASSO right down here. So I think we should be able to just power it on and see what happens. Cross your fingers. I see life. Nice. I'll admit I was a little bit worried about whether that ribbon cable was going to carry enough current, but this looks just fine. Need a password, 1, 2, 3, 4, 5. Then we should be able to e-stop it and release. And there we are. Home, it's not set up, but I'll just double tap it to home. Okay, now we're homed. So X, and we are moving. Y, Z, okay. MPG works. And let's go to setup so we can see our inputs, 1, 2, 3, 4, 5. I'll just use a couple of screwdrivers and we'll short power to input 7. And there it is, turning red there on the screen. Try input 8. Yep, input 9. Yep, okay, so that's working. So the next thing we need to do is hook up some of the outputs to the relays and then verify that we can control those. Let me crimp a bunch of wires, hook those up, and then we'll test it. You know, wiring takes a long time. I've been working on this all afternoon and taking my time and labeling things and doing things right. And I think I am at a point now where I have all of the power and all of the switched power systems set up. So I've got the outputs from the MASSO connected to the 12 relays, and then I've got power connected to the relays, and I've got a few of the relay outputs connected. One of the relays goes to this relay that then switches the IPC5 power supply on and off, and then there's a couple more that go to these other relays, and I think once those are all hooked up, that is the last of the switched power systems. So let me go ahead and finish the last one here just so you can see what's involved in one of these circuits. I've done this before on the channel, so I'm not going to spend a huge amount of time on it. So I'm just using, in this case, 20 gauge 600 volt machine tool wire. Strip the end of that. Put a ferrule on it. And then crimp that. This is a Knipex ferrule crimper. I've shown this in previous videos as well, and this tool is magnificent. I've got a printed heat shrink label here for it. Put that on and then shrink that just using this. This is a rubber stamping embossing heat gun. That's going to come from the output here. It's going to get routed around. And it's going to come to right there. And that should be it as far as the AC power switching. And we should be in a position to test this thing. Okay, the MASSO's up and we're flashing the red and yellow lights. Okay, the first thing that's switched here is the IPC5 power supply. That's based on the e-stop output. And so we can see that's energized and the relay is energized. And I don't know if you can see that, but the light is on the power supply. So we should have voltage on the output. And we do, 75 volts. But then if we hit the e-stop, that should de-energize. And there is the shutdown light. And sure enough, it has powered off. This is de-energized, this is de-energized. When I release the e-stop, it comes back on. Great. So that is the switch power complete. I'm going to call it a night for now, and then tomorrow we'll wire up the servo outputs now that we've got servo power and see if we can actually get some motors turning. Incidentally, the reason that I go slowly like this, wire part of the system, test it, wire part of the system, test it, is just a financial one. I make mistakes like everybody else, and I like to catch those mistakes as early as possible before they have the opportunity to explode and hurt expensive equipment or people. So, you know, I tend to start out very, very simply, wire the main power system, get it to power up initially, get the controller up, and then just start adding output circuits one by one so that I can make sure that each thing works as I go along and I don't end up with a big bang integration, or worst case, a big bang when I try to do integration at the end. So this is just a habit I picked up with from software development, doing very small incremental steps and checking the results as you go. And it serves very well for something like this as well. That's all. I'm gonna get some dinner, I'm gonna get some sleep, and we'll work on this some more tomorrow. Okay, I got some sleep and had a think, and this is basically what we have left. We've got all the connections that come down to the breakout boards, so these custom PCBs that I made. And the good news is, when we look at the connection list, it's just all of this stuff. So I've broken it into sections, and we'll tackle these one by one. But the first thing that I want to do when I start actually bringing the connections up here is to deal with this ribbon cable that actually right here, this ribbon cable that carries the step and direction for all 5 axes as bidirectional signals. That's got to come from the board here on the MASSO out and around and up to here. And since that's a ribbon cable, and since that's the sort of widest and the most difficult to route, I'm going to do that first. Now the good news is that these little connectors are much easier to crimp than those giant D connectors. And so I will start out by just kind of figuring out which way I need things to go. So that's going to fit there, and I want the cable to go in that way and out over the top, which means it needs to come in here. Make sure the black wire goes to pin 1, and then bring in my connector press. And crimp it down. So like I said, these are much easier. Okay. Now I just need to figure out how to route it. Okay, now unfortunately, I had to put an extra little twist in here because the black wire was on the wrong side, and that's just what happens sometimes, but I think I've got that routed. It's tucked down nice and neat next to the other one, and it comes up and connects here. Okay, with that done, we need to start connecting to all of the screw terminals here, and there are a lot of them, and they're done up in different groups. So the first group is the power group, and that's all of these over here on the side around the end here, and those are things like magnetic loads, like driving a brake, driving the air valves and the lights for the tower. And then the next group over are the actual inputs, and so those are all relatively low current inputs. Then the next group over is the spindle, and then finally all the stuff related to the ClearPath, stuff like the servo OK signals and the enable line. And so my plan is, since I'm going to bring all of these cables up and around through this tiny little channel, I'm going to start from the far end, I'm going to lay these things in, and I'm going to do them one group at a time. And to make this easier, I've gone ahead and put together some wiring harnesses. I've got enough wires in each one of these groups. I've got the ends already crimped and labeled so I can put those into the terminals and lay these down one group at a time, terminate them, and then lay the next group over the top, and the next group over the top, and the next group over the top, and so on. And I'm pretty sure I'm going to have enough room in this tiny little finger duct up here at the top to carry them all. So there's really nothing to do but get started. I'll start with the power group, get them on the terminals here, route them, and lay them all down. I think the easiest way to do this, though, is going to be to pull these out and make the connections and then put the connectors back in. The other thing that's worth noting here is that because of the orientation of the board and because of where I put the labels on the PCBs, the labels are now underneath the connectors from my point of view. So even if I bend over and stick my head in the way and try to look in there, I really can't see them. So at least for this job, I'm going to work from a spare board that I have, and I'm just going to look at the labels here and hook everything up. Now with those routed neatly and laid down, now I'll just cut, crimp, heat shrink label, and terminate these connections where they land. And I'll be back when I have that done. Well, those laid in there beautifully. I really like the way they're fitting into the wire duct across the top here. I like the way they're kind of looping down the side, and they're fitting nicely into the trays, and everything was long enough. That's a nice bonus. One thing I did to make this job a little bit easier is I cut some little short pieces of the cap for this wire duct, and that allows me to just snap this on and keep the wires in place. And I'll kind of move those as I go down. But I think at this point, all I need to do is just finish this job and go ahead and wire all of the rest of this up. We've got the stuff for the ClearPath board, we've got the rest of the I/O, and we've got the spindle. Well, let me get those wires in here, and then we should be almost ready to test. Is there anything else? Yeah, servo power. But then we should be ready to test. Okay, that is all of the circuits complete, and they all buzz out. Everything looks okay. Last thing we need to add is the servo power. And I went ahead and made a couple of cables. These are just the Molex Sabre connectors, and I went ahead and just made a set of these. I bought the one from Technic and then cut it off and crimped new connectors on. And we'll hook both of these to the same power supply. But then I have these sized so that I can route the cables around this side of the supply rather than going over this side. That way they're both long enough to hook onto another power supply that goes next to this if I add a second power supply to the system later. And unless I've made some terrible mistake, I think that is everything. Though I probably am not going to put this in the bottom tray there. We'll just leave it outside the tray like that, and we should be able to put everything on. So you note the way this is all laid out. All of the AC power is right around here and over across the bottom to these power supplies. The furthest over the AC power comes on the top is just right here. So all of the AC power is here, and then from here over, this is DC. And the 5 volt and the 24 volt supplies, and all of that comes up and wraps around this way. All the signal wires come up, come across, and go around this way. The only thing that's next to the signal wires at all is this servo power. And if I needed to move that just outside the finger duct, there is enough cable. I could do that. I'll probably leave it in the finger duct. I don't think it's going to be a problem. It's 75 volts DC, and as long as there's not a ton of noise on it, it should not be an issue. Okay, given that I think everything is wrapped up, let's go ahead and put the covers on. Do you see anything I missed? I don't see anything I missed. Well, I think I've done everything I can to make sure it's wired correctly. I grabbed a multimeter and went through and tested continuity between all of the connections on the outside and the terminals where they're supposed to be connected inside the cabinet, and I think everything is good. So let's actually power this thing up and do some end-to-end testing. If you hear any background noise, it's a really windy day. We got a storm brewing outside, and you might be able to hear some of it. Okay, let's go to the setup screen so we can see the inputs. And I haven't programmed anything, but this still does show all of the inputs, and so it's possible to see all of these and see the state of them. We can start by testing the unclamp input. This foot pedal will be for releasing the tool, and I've got an input for that. And I've got a 4-pin cable. So let's just go ahead and hook it up. Now, this foot pedal is wired for both normally open and normally closed. The 4-pin A-coded M12 connector has a power and a ground, a normally open and a normally closed circuit. I have both the normally open and normally closed set up to switch to ground, and that'll allow us to test any of these inputs. Because the unclamp input is normally open, that way if a wire fails, nothing will fall out. Okay, so if we press this, one of these should change, and there it is, input number 13. Okay, that looks good. Let's try the touch and probe inputs. And again, these are normally closed. So there's the touch input. And there is the probe input. So those are all the mechanical inputs. We've got outputs we'll test in a minute. And we've got inputs for all the homing switches. Those will work with this as well, but they're intended to work with an inductive proximity sensor. So let's give it a try. Now the main difference between the inductive proximity sensor and a mechanical switch is that the proximity sensor requires power. So I'll plug this into the X home, and we should immediately see that change because it's a normally closed switch. And there it is, we can see that's low. If I bring some metal up to it, it switches. Okay, that's X. Let's go ahead and test the rest of them. There's Y. There's Z. There's A. And finally the fifth axis, B. And that is all of the inputs. See, for outputs, we've got the valves. We can test those. I have those handy. We've got the brake. I'm not set up to test that yet. And we've got the tower lights, which I'm also not set up to test, but we can plug in and try the valves. So this is an 8-pin M12 connector. And then we can connect that up to this valve body that I put together with M12 on it. I showed this previously. So none of the valves are activated. This should be the coolant mist. And there it is. Can you see that LED? Yes, you can. So that's activating. Let's go to the chuck unclamp. There it is, number 2. Then the tool setter air blast. There it is, number 3. And then the auxiliary valve, which I haven't assigned anything yet. And there it is. Okay. Those are all the inputs and outputs working, at least the ones we can test now. Now if I hit the E-stop switch, this will activate some of the tower lights. And so you can see the tower light red and yellow are flashing. And I can hear the relays clicking. So I know we're good there. And then if I go back here, they're all off. Okay. Again, I don't have anything hooked to the output, but I can hear it. It sounds good. So what do we have left to test? We have the servos. Now I don't have all of the servos here ready to go, but I do have an extra ClearPath servo that we can use for testing. And I've got some cables to hook those up. And because the 72 volt power is live, I'll go ahead and hit the E-stop. That should turn that power off for when I connect the servo. Okay, we'll connect up data cable for X and the 75 volt power. And we got no lights, nothing is happening, which is exactly what we would expect because the power should not be on. And then if I release the E-stop, okay, I just heard the servo come on and it is now locked. Stop that. Now this is X. We should be able to get some motion out of this. We'll use the tried and true YouTube flag of blue tape so that you can see it turning. That should be X. And we have nothing, but we have nothing up here too. Why is that? Oh, let's go to the jogging screen. There it is. Okay, I clearly don't understand everything that's going on with the jogging here, because I know sometimes when I'm jogging this, I get no motion. Like right there, I get nothing. If I slow down, I do get some. So there must be something about the way the jogging works in the MASSO. But what I see here on the X coordinate is matching what I'm seeing on the motor. Yeah, so that's just the maximum. That's the end of travel. But that is working. Now I'm going to leave it powered. I'm just going to move the data over. And we'll go to Y. And then we'll switch the axis to Y. Okay. There's motion on Y. Switch over to Z. There's that motion on Z. Switch to the A axis. Here we'll go to 4. And I don't see anything, but I don't have anything configured for that, so that doesn't surprise me terribly. Okay, no, there's 5. 5 is moving. When I plug into A, 4 does not. When I unplug that though, it does release. So the enable's definitely working. Ah, I see the A axis is slave to the X axis. Let me turn that off. Try that again. And there it is. Okay. So all of the servos are working, and if we hit the E-stop, the servo de-energizes, and the power is actually cut too. So we're de-energizing the enable, and we're cutting the power. Release that, and now we are back in business. Excellent. The only other thing that I have to test that I can test easily right now are the auxiliary power outputs. So let me hook up some power and let's test those. Now these are of course set up so they are each on their own circuit, and this one should be live. Yep, you can see the lights are on there. That's when main power is on. If I turn off the main power, that'll die as well. So power that back up. And then let's connect power auxiliary 1. Now that should be output 10. And there we have power. And then let's try auxiliary 2. There it is. I think that's all we can test. There's a Hannibal Smith joke in here somewhere, but I will just leave that to your imagination. Well, the control cabinet is now done, and we should be ready to install it on the machine and switch our focus to the mechanical systems. We need to install some ball screws and some motors. We need to install some sensors. We got to get things set up with the probe and the touch off and figure out the programming in the MASSO, and we should be well on our way to making parts. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. If you've got any experience with the MASSO or any tips that would save me a bunch of time and trouble, put those down in the comments too. Thank you for watching.